Hello guys, good evening. I hope you all can hear me. Give some response in the chat or in Q&A. Give some response in the Q&A, everyone. Tell me that I'm audible. Please confirm me a message regarding that you all can hear me or not. So guys, let's wait for another 5 minutes. Please ask your friends or whoever it is you know from this class to join the meeting as soon as possible. So they're already delayed by 10 minutes. So we need to cover the topics. As yesterday, in the previous class, we discussed only the basics of the NumPy and everything. So we'll go in depth of this topic. So please bear with me and also ask your friends from the session to join as soon as possible. That's a request from my end. So hello class, good evening. I hope everyone has joined the session so that we can start. And the learning objectives for today's class is NumPy, Pandas, Matplotlib, Scikit-learn, the whatever topics we can cover from this libraries, we'll cover from them. So apart from the previous class, we had the basic introduction and we know what errors we'll get if we are performing some operations. But in this class, we'll only focus on the libraries, how they're performing and what are the functions we'll get from these libraries, how these libraries can extract more data visualizations and more help to the machine learning in future for data science or for other learning tools. So getting into action, I just share you my notebook. I hope you all can see my collab, right? Give me some response. Guys, I hope you all can see my NumPy notebook. Give me some thumbs up so that I can proceed that. Yeah, so basically we have learned that NumPy is nothing but numerical of Python. So what are the numerical operations we are doing in Python, we'll do that with the help of NumPy. And also these operations we'll be doing with NumPy because NumPy has some advantages. Okay, so we'll be learning in this session called as why NumPy, so how to create NumPy arrays and how to understand the arrays, and also we'll perform some slicing operations and some other operations in this NumPy. So the first we'll do the introduction of NumPy. So how NumPy was handled and how NumPy is used to solve the equations. And apart from this, why we use NumPy. So we'll learn this one. So the first thing, we all know what is a Python list. So a list in the Python is a built-in data structure. So in this Python list, we can store, it is mutable and it is of heterogeneous. So we can, in list we can store, as you can see in this R list. So this list is of name R, and here we have one is numerical, the second one is of type float, and this is one of type int. So in list we can have heterogeneous data format. So unlike NumPy, NumPy is a homogeneous array. So in this homogeneous array, but what are the data points we'll be having in this array? We'll be having everything in the same data type. So coming to list, it is of different case where you can have multiple data types. Okay. So let's find out how we can perform operations with Python list. So before learning why NumPy, we need to learn what is the use cases that were there before and why NumPy came into existence. So solving the problems of previous functions and everything, NumPy came into existence. So we'll discuss that right now. This thing is, so in this P, R, and T are nothing but principal, rate of interest, and time. I hope you all know what is simple interest. So simple interest will do the calculation where P into R into I slash T. So here we're having array. In this we are having P, R, and T. So what we need to do is P into R into T slash 100. So we'll get simple interest. Okay. So first we'll form this operation. We'll run this cell. So when you run this cell, you're getting simple interest for each case is 100.0, 450.0, and 180.0. Okay, what are you doing is you're using a for loop. Okay, without for loop, you cannot get this thing. Okay, if you look at this thing where rather than writing, I'll just copy this one. Okay, you cannot get this one because here I represents the thing which is iterably changing between 1 to next. So what are the indexes you're having? This I will replace the index values. I hope you all know how for loop works. So without for loop, we cannot perform this simple interest function in Python. So what this for loop is doing is what are the computation you're having? Suppose as it is only 3 values. So I will change from, let me show you here. First, the problem is length of P. Here length of P is nothing but length of P is nothing but 3. Okay, R is 3 and also T is 3. So we won't be having any problems. But coming to some mathematical complications where you'll be performing, there you'll be having where length, suppose imagine length of P is of size 1000, size 500, and the size of 10,000. So here when you're performing operations in this 1500 and 10,000, what are the operations you'll be performing? For loop, for this for loop, you'll be having a large time complexity. So if you're having this larger time complexity, this will have some mathematical complexity in the background. That means when you're performing tasks with this much, the for loop will run for a while. So whatever the equation you're running, it will take somewhat time, not just minutes or something. It will take some seconds. So we can think that it's some seconds, so we can perform this no matter by this number. But coming to banking equations, suppose if you are making some transaction, whatever the transactions you are making, it will happen within microseconds. But whenever the transactions are happening in second, you need to wait for minutes so that you will get a confirmation that the money is debited from your account and credited into another account. Suppose you want to pay to a hotel or some other bus stop or some other place, you need the transaction to be made within an instant. Within a second, you need the transaction to be made from one bank account to another bank account. So at this place, this comes into operation. So NumPy is a thing which understands the vectorized code. That means what are the code you're doing? It is of vector format. It is of 2D vectors, 3D vectors, 1D vectors. And also why NumPy is faster? Why NumPy is faster? Because what are the code we are running? It is with the help of C programming interpretation, NumPy is working. That means whatever the functions we are having in NumPy, it is similar to C. So I have already told you what is the difference between Java and C. So Java and Python. So one is interpreter and one is compiler based. So the compiler based is a programming language where the program is changed from human readable format to machine readable format. So NumPy is a thing which will form this kind of understanding. So where machine understands this NumPy, so numerical equations will be calculated within seconds. So if you want to perform some operations with Python disk, you need to have a for loop. Other than that, you need to have some. You're also performing the for loop where let's run the cell. P into T uses is 2000, 6000, 3000. Okay. So I'll show you what is the use of NumPy arrays. So here we are defining the PTR is equal to np.array. Now let's look at the NumPy first. First, we need to import NumPy as NP. Okay, the NP is a global standard form for NumPy where you're importing. So it's just normal common form. So wherever you're writing, if you don't write this and NumPy as NP, you need to write this everywhere where NP must be replaced with NumPy. Okay, so let me show you. I hope you all know how alias works. Okay, now this program works. Now when it changes as NP, you need to convert them because Python doesn't know what is NumPy. Now we have renamed the NumPy as NP. And going down, yeah, that's it. What are the code we are having? We have renamed that to NP for the library NumPy. Okay. So the core concept of NumPy is something which is called as ND array. So if you want to know what is the type of this one, suppose if you want to copy this, if you want to know print type of this, then you can see the type is of list because we're not defining anything before. But when you define something as np dot array, the brackets are here. Now if you run the code, now we're getting the class as numpy dot nd array. So what is the difference between both? So let me just clear it up. So main difference is that we're not having np dot array. So what this np dot array does, it converts a, so make a note of this thing, guys. Sorry. So np dot array is a function which will convert dot array will convert either a tuple or a list into another. So that is what it has given already. Okay. I hope you can understand that input array will convert either a tuple or a list into an array. So now you are seeing that whenever list is defined, it is defined in a way like this. So let's take an example. L is equal to 2, 3. Okay. If I take this print type of L, okay. Now if you see this one, we can see it as, let me just comment this for better understanding. Now you can see the classes of list because we are printing the type of L. What is the type of L? It is of list. Now, if you carefully change this, now I'll take D. Now I'll convert to 3. Now, if you want to know the print type of D, now the type of D has become a tuple. So I hope you all know the difference between tuple and list. Tuple is a data type where it is of immutable. That means if we perform an operation, that means we cannot change anything. So even if you want to change this thing, like let me just d of 0 is equal to 1, and if I want to print d, sorry, that's not how it works. Just okay, now it is, sorry, yeah, it is showing that let's not assign the object after creation. Okay, now if you perform an operation for L of 0 is equal to 1, and now let's print L. All it does, now it has changed the index of this one. Index of this is 0. Index of 2 is 0. Index of 3 is 1. Now the index of 2, this one is changed to 1 and this one is asterisk because we are renaming only the 0th index. We are renaming only this index number with 1. So what are the thing we are doing? We are doing it with only replacing with 1. So if you want to print this, it is of mutable list. So what is the thing we are having is tuple is of immutable and list is of mutable. So going back to the basics. Sorry, we just type complete this into a list. Okay, now we'll get back to our main topic. Okay, now what we are seeing is we are seeing the class of this thing as list. Now what I can do is we can convert this list into a tuple because as it is told that numpy np.array will convert either a tuple or a list into an array. That means even if this thing, so if this thing, it might be an array or it might be a tuple. Sorry, it might be a list or it might be a tuple. Whatever the form it is, whatever the form structure it is, whatever the form it is, we don't care about that. Either it must be a list or it must be a tuple, so that we can convert as per our convenience into a numpy. So now this data type is of numpy, and after that we can directly perform some operations. So as numpy stands for mathematical calculations, what we are doing 5. So 1000, 2, 5, 2000, 3000, 3, 1, 7.56, everything. We are multiplying with P into T into R by using division with 100, and now we are getting the simple interest. That is 100, 400, and like what is it? 800, 180. Okay. Now that is the thing. So coming to the NumPy basics, we have already discussed this NumPy basics in the previous session, but we need to revise because it has been a long gap between the last session and now. So if we want to create a single array, we can call it as 1D array. That is NumPy in 1D array. If you want to create a 2D array, that is called as array 2D. So whatever the array you're creating, if it is of n dimension, we can replace n with our preferred value. If it is one dimension, you can replace it with one dimension. If it is a 2, you can replace it with 2. Hope you all got the point. So guys, please give me some responses. I want to see you that you have understood the point or not. So yeah, going to the NumPy basics. Going to the NumPy basics, as we are discussing, one-dimensional array is something which we'll see like a list, and the two-dimensional array it will be something like similar to a table. And coming to the three-dimensional array, it is of a matrix format. It's of a cube format. So as we cannot see a three-dimensional array, we can only see the cube format of the like a matrix format of the array, and so on. So whatever the data types you're having, it is of homogeneous. Either it must be an integer or it must be a float. Remember one thing, NumPy is a homogeneous. Every data type, so every data elements that are in this data must be of same data type. No, nothing of unusual, nothing of dissimilar data types. Everything must be same, either integers, decimals, or float. Okay. So this homogeneous data, why we are keeping it only homogeneous, because the reason why NumPy is so fast because of the thing called it is having only homogeneous data. Okay, whenever you're having of similar data, there is no reason for finding any any irrelevant data that we are having in the list or array. So if you're having a list, in a list you can have heterogeneous elements. So in this you can have characters, floats, integers, and everything. So in this point, if you want to form some mathematical equations, this list needs to be analyzed first. So whether it is having all numerical or not. But coming to NumPy, everything will be in heterogeneous format. So either float, either decimal, or integer. Okay. So as we have discussed, NumPy is short form for numerical Python, which is efficient for operations of mathematical calculations. And as we all know, we'll import NumPy with the help of np.array. NumPy is array built-in Python built-in function. With this, we can perform the mathematical operations, and these are mostly used for efficient storage and data operations. So as the array size goes larger, they cannot perform the operations in lists or tuples. So that is the reason we'll go for NumPy. It is homogeneous data storage. What are the data you're having is homogeneous. So why it is because mutable, because we are only converting data from lists and tuples. I hope you got the point. We are only converting the data from lists and tuples. NumPy arrays are nothing but the data we are converting from lists and tuples. Okay, whatever data you're having in lists and tuples, we're only converting that into NumPy. So the thing which we have done before, importing NumPy as NP. Whenever you import NumPy as NP, only we can perform the functions. So if this cell is not performed, we cannot perform these further operations. So here we are seeing how to create a NumPy array and how to print an array. And also checking the data type, that is the next array we'll see. So it's a basic operations we're doing. Import NumPy as NP, that is we are importing. So even if you're using Colab, if you go for this NumPy, it will show you the what is NumPy and everything. So array is equal to np.array. Here we are defining array. Array is a variable. Sorry, ARR. ARR is a variable here. So you can rename this with just AR, and you can give it AR. So AR is equal to np.array 100 to 100. So if you are printing AR, you'll be seeing a type of this print. In the type function, you will give AR. Now, if you are seeing this, it is giving you the class as numpy.ndr. So in this nd array, this nd represents the dimensional size, whether it might be 1, 2, or 3. So whatever the dimensions you are performing, what are the operations you are performing multiple dimensions, this will come in this category. Okay. I hope you got the point. Please give me some reactions, guys, whether I'm getting too fast or too slow. So next thing is we are knowing the type of functions. So as you all know, this is a type of list. In this, you are having multiple lists. In multiple lists, you are having another part of list. So coming to this, now we are converting that into type of NumPy. So how to create 1D array? We are converting a 1D array. Now how we are converting a 1D array? That is because we are using array of np array, and here you can see print. If you print this one, you can see only one row. Okay, so whenever you're having one row, it is called as 1D array. So as you can see, the type is already executed. The type is of np, numpy, and nd array. So here we are creating 2D arrays. So how we are creating 2D arrays? In a list, sorry, in a numpy, in an array, we are having two lists. So if you are having two lists, that is called as 2D. If you're having three lists, that comes under the category of 3D. Let me just check whether it is working or not. Okay, it is working. So what we are doing is we are renaming this one into array underscore 2D. So there is nothing with the naming. If it is array underscore 2D, we'll only get 2D array. Okay, this is just for naming purpose. We have given the naming as array underscore 2D for understanding. np.array is equal to this in a list. This is the function, guys. This first bracket comes under first function, and in this you are defining a list. Okay, even this you can define tuple also. Let me just check we can define a list tuples in this. Yeah. So what we are doing here is the first bracket. The first bracket, that is the np array. This is a function. Okay, in this function we are defining the elements. Okay, so in this, if you are defining the elements, the first thing is creating. As it is, if you are having only one element, if you are having only one list or one tuple, that means you can use there is no use of using this thing. Okay, there is no use of using another bracket. Why we are using another bracket? Why we are using this one? Okay, it might be a closure bracket, sorry, it might be a box bracket, or it can be a oval bracket. So why we are using this one is because we are creating ND arrays. Okay, if you're having only one dimensional, you can directly use this single thing. Okay, you can directly use this thing. There is no anything of another brackets. So if you're want to create multiple, then you will be using this. So in this, if I'm having 1 comma 2, and again I need to have 2 comma 3. Now what it is doing is, sorry, forgot to mention the brackets. Okay, now what it is doing is, this is the function. So remember to remove this one. Okay, now I hope you understood why the final one is. So why it is this? It is because you are combining multiple tuples or multiple lists. So here we are having, in a list, we are having multiple tuples. If you rename this to this one, that means in a list you are having multiple lists. So if you convert this to this, so NumPy will not care whether it is a list or an array. Okay, the complete thing, whether it is a list or array, it won't care. And in the minimal elements also, if it is a list or if it is an array, it won't care. Okay, I hope you got the point. Whatever the functions we are having, we need to convert that into multiple dimensions. So I hope you understood this one. We have created a 2D array. So sorry, we have converted 2D array. Until this point, we have converted 2D array. Okay, now we'll discuss what are the advantages of NumPy. So in NumPy, dimensions are called axes. So whoever told that we know NumPy, I hope you know this axis thing. So axis of 1 is called, axis of 0 is called as rows, axis of 1 is called as columns. Okay, don't just sorry, don't get confused. What is axis, what is 0 and 1? I'm here to explain you what is axis and everything. Suppose we'll look at this axis in the upcoming. So just leave it right there. So coming to the advantages, what are the advantages of NumPy? Okay, why NumPy is specifically used for data analysis? So the first thing is because it is convenient to use and the speed. So the speed is the main factor which is helping us to work with NumPy. So, okay, if you are with list, the list is taking some time because it uses some looping concept to run the elements in the list. If you want to perform the entire mathematical complex in a single second, NumPy is an option for you. And why we are using, why it is fast? Because vectorized code typically does not contain explicit looping. Okay, as it is a vector format, matrices format, does not require any looping format. And also this happens in the behind scene in precompile C code. Okay, as we have discussed, it is a compiler based thing, compiler interpreter, compiler thing and interpreter thing. So it's of C program. In the backend, it runs like a C program and it gives us a fast output. Okay, so if you want to multiply two things, that is list 1 into list 2. For example, list 1 is this thing and list 2 is this thing. Okay, if you want to multiply these two, it says that we cannot multiply these two. List 1 is not defined. So sorry, let me just define these things first. Okay, now the thing we are seeing is we'll get an error, of course, because we cannot multiply a list. We cannot multiply the list. So I hope you all know that list cannot be multiplied. Then what is the options? We can either use for loop or we can use lambda functions. Okay, so lambda function is also known as anonymous function. So this is a small anonymous function used for only single operations. So here, if you want to multiply list one and list two element by element, the first way is we will be using mapping to form the mapping between the elements, and after that we'll be using the lambda function. So lambda is known for its small anonymous function. To achieve this, it is not an immediate intuition. That means whatever the thing you'll be doing, it will take some time. So first we'll convert this into first we'll map this thing and we'll perform the operations. So I hope you can get this point. But in the NumPy, what you're doing is first you're converting the array one, array two. So whatever the thing you're doing, you're converting the list one, that is 3675. So here it represents 3675. 4517. Here it represents in the list two, it represents 4517. What we're doing in the name of array one, we are converting the list one using np.array. In the name of array two, we're converting the list two into np.array. So now you are converting list one and list two and assigning the newly converted np.arrays into array one and array two. What you're doing in the array three, you're multiplying array one and array two directly. That means you're multiplying np.array of list format. So whatever the list you're having, you're converting that into np.array and you're multiplying them directly. After that, you're printing array.array. So for our understanding, I have written this print of type of array underscore three. So this array underscore three represents the type of this numpy underscore array. So let me just print this thing. So this is what we are getting. So creating numpy arrays, we are having multiple ways to create numpy arrays. The most common way is using this np.arrays, np.arrays. As we have discussed, we need only lists or tuples and we use np.arrays. Okay. So what we are doing is np.array. Okay, in the inside you can see this is a list format. 2567 is of list format and 4589 is of tuple format. Let me just show this in detail. Okay, now, oh sorry. Now we need to get this, not this thing, L and T. Okay, now you can see the L is of list. Okay, and T is of tuple. Okay, this L is nothing but 2567. This one, the first thing you'll be seeing 2567, and this T 4589, something but this thing. Okay, so if you want to know the type, one is of list, one is of tuple. Okay, so whatever you're doing, what you're converting them to np.array. There is no differentiation between np.array of tuple and list. What are the formalities? We'll directly convert them from list to tuple. So we'll directly convert them from list and tuple to numpy.array. I hope it is clear. Give me some emojis, guys. Some clarification that you understood. And I want to check how many participants are there in the meet right now. So there are around 60. Anurag, I'll check with my network issue. So if you're having an issue, I'll just check with that. I hope you guys are understanding this one. So in the previous class, we just played with the numpys. We didn't do anything. Now we are getting into the concept. Thank you for confirming that my voice is audible to everyone. So we'll resume the class from where we have left. So I hope you are learning something from the session. So apart from the yesterday's and previous days class, we have just touched up the basics. So now we are going some deep into the NumPy. And after that, we'll go for pandas, matplotlib, and every library which we have discussed in the previous class that we'll discuss further. So as promised, we'll go for every library, and after that, we'll go for the EDA. We'll go for the machine learning terms, machine learning fundamentals, and after that, we'll learn the algorithms. Don't worry about everything. We'll cover everything, and later only we will be introduced into the project-based learning. So the other common ways to initialize arrays. So this is what we learn. So you can play with these guys. We'll have a class until 7:10. After 7:10, I want you all to perform some operations and put that in the chat box. Okay. So first thing is they're having np.ones. Okay. So to learn this, the following ways are commonly used. So if you want to create an array of only ones, okay, that means you only need one. And if there is any particular situation where you only want separate number, okay, where you only want twos, where you only want random numbers, okay, then we'll call this function where that is called as np.ones. So in this np.ones, so this is 5 and 3. Here, as we have discussed, axis 0, axis 1. So what we discussed, axis equal to 0 and axis equal to 1. Okay, now you will understand what is the meaning of axis and everything. Okay, so this represents row. Now this represents COLUM and this columns. Okay. Now what this 5 represents is rows. What this 3 represents is columns. That means this is of index 0. So why we are calling is axis 0, axis 1 is because in this np.1 in this list, 5 is of index 0 and 3 is of index 1. As you all know, mathematical machine learning mathematics starts from 0. This represents rows and this represents 1. So if you are performing this operation, they're getting 5 rows and 3 columns. Okay. You want to replace this with 2, then you'll get 5 rows and 2 columns. So I hope you understood this one. Whatever the axis, that is 5 comma 2. Okay. If you replace this with 1 comma 2, that means we'll only have 1 row and 2 columns. So I hope you understood this point. Now we'll create zeros. Okay. So I want to let you know that why we are having this dot. Okay. Why we are having this, what we call float function. Okay. So before looking at something, I want you all to give me some response in the chat box why we are getting this. So to break the tension, I'll just explain why we are getting this. So what are the functions we are performing? It is taking in the form of float. Okay. It's taking in the form of float. If you want to perform some operations, that means you need to call that as it is given. It is given with the help of AI. Now, if you run this function, it is giving us d type is equal to int. Why we are getting d type is equal to int? We are converting this 1 comma 2 array, whatever the function which we are going to create, what are the array which we are going to create using numpy.pandas, sorry, np.array, not the pandas, np.array. This is of integer format. Okay, if you want to convert this into float, we can directly give it as float. Then we are getting 1 point, 1 point, sorry, 1 point and 1 point again. So what we need is we need a format of integer. Now we are getting 1 comma 1. If I want it in a 6 comma 5 format, Now I'm getting 6 rows and 5 columns. Everything is on integer. Now if I want to get 4 rows, so I hope you will understand this thing. Why we are having here two brackets. One is closed and one is open. Okay, this is for the function. In period one's function, we are having a one bracket here. And also here we are having one bracket for the function. But why we are having two brackets here? Because we are defining 2D type array. But here we are only defining 1D type array. If I want to have 2D type, then I need to define like 4 comma 3. Now we are having two brackets again. Okay, I hope you understood this point, the difference between having single bracket and two brackets. When you're having, so let me just show you why we low. Okay, if it is, we are performing with this type of operation, it will say that we are having argument for zeros. That means it is saying 1, 2, 3. And the data type in the position 1 is not defined. So np dot zeros. That means the first thing is np, numpy. What numpy will identify? Only list or tuples. That means you need to keep it in list or tuple. So if you place it like this, it will understand that it is a tuple. We need to convert this tuple into a np.array. So this converted as 4 comma 3. That means 4 rows and 3 columns. Data type is float. If you don't define this thing, if you don't define the thing and only this thing, everything will be converted into float. That means 0 point. Okay, if I want to define this as d type is equal to, we are having decimal. So it says that name decimal is not defined. So what are the functions it is having? It will only define that thing. So what are the predefined functions you're having? It will only accept those. So as int is a variable, so variable type, what are the sorry, what are the data types you're having? If you're having in the form of int or float only, then we can adjust them. So coming to np.random. So this is a function where you will be getting random numbers. Okay, if you don't want to have if you don't have an idea what numbers you'll be getting, what numbers you want in an array, then you can go for the random. I hope you all know what is a random library. And random is a library where you'll be getting random inputs or random outputs from a predefined thing. Suppose you're having a predefined thing. Suppose you're having a list of 100 elements. If you want to get some random elements, I hope you all know how to play snake and ladder. In a snake and ladder game, you'll be having a dice. In this dice, you'll be having 6 numbers. So whenever you're getting a 6, whenever you're getting a 5, whenever you're getting a single, we don't know when we'll get. Okay. So that means we are getting the numbers in a random format. So in this way, we'll having a function. Sorry, we're having a library in Python called as random. So with this library, we can get random elements at the places where we want. So this one will create a random float between 3 comma 4. So as mentioned here, we know that this one is axis 0, this one is axis 1. Okay, if you define this thing, okay, let's run this thing. Now you can see every time we are running this cell, the inputs are changing. Whenever you run this thing, the outputs are changing. That is because we are performing the function of random. Whenever performing a random option, it gets a 2D of 3 comma 4. As we have defined 3 rows and 4 columns, we create a 3 comma 4 columns array. Now this is filled with random decimals. Okay, now these are between 0 and 1. This is great for performing weights in machine learning. Okay, what are the weights we are having in machine learning? This is great for having these functions to perform the operations. And coming to the next thing, that is we're having a thing called as arrange. So I hope you all know what is this thing. So I want you all to comment what is this thing. What is the thing that is mentioned in the comments? So what are the things that I have highlighted? Please mention what is this thing. But only single response on some other responses, whether checked it is a correct response or not. I have 55 participants in the meet. I want every participant to respond. So am I having any network issue that I cannot see the response? I can only see 4 or 5 responses. So if not I'm having any network issue. I need to see some 20 with the responses, but I'm only seeing 5. That means I must be having some network issues. So if I'm not getting more responses than this, and if I'm having stable network issues, like if I have a stable network connection, that is disappointing, guys. I need you all to answer what is this thing. What is the 2 lines of code that I highlighted? What we call that thing? If I'm clear, I need to get some responses. I thought I'll get more than 30, but it's okay. Listen, I'll listen the count to 20. If not 20, at least 15. Come on, guys. I'm not asking for more. So when I told I need some 10 to 15 responses, I didn't mean that I need to get all the responses from a single person. Thank you for the person who is keeping multiple responses, but I need to get responses from each and every individual. Yeah, I want everyone to answer in the Q&A. I can see the Q&A. So in this Q&A, I want you to ask me any doubts, and I want you to answer the questions for which I'm asking you. So I think I got only 10. So are we a class of 10, or we a class of 54? So now there are currently 54 participants. So while I was explaining the Python basics and everything, someone told that they know Python, they know NumPy, Pandas, Scikit, and everything. Now, not see more responses than 10. That if I ask about what is this thing, no one is commenting what is this 2 lines of code. Someone is facing troubles with for loop. We need to go back to the basics. This basics will include explaining for loop, while loop, control statements, and everything. So shall we go back to the basics, or shall we stick to the class? Hope someone need this thing. Come on, guys, stick to the class. Yeah, I'll stick to the class, but I need to get some responses, guys. So this is a basic for loop. You'll be seeing this in a day-to-day life. Whenever you're doing some coding in Python, you'll be seeing this thing. So this thing will help you to perform operations when you're having a list tuple or some other thing. So if you want to arrange, I hope someone answered this thing. So this is how many elements I need. So this is the index count. So this is, let's take an example. Okay, it is given here. So from 10 to 100 with a step of 5. So with the 5 count from 10 to 100, that means 10, 15, 20. This 10 is inclusive. Okay, this 10 is inclusive. Okay, this 10 is inclusive. This 10 is exclusive. This 10 is inclusive. 100 is exclusive. And this is a step. This is a count that needs to be maintained. Okay. So if you run this thing, it gives 10, 15, 20, and so blah blah until 95. So, but if you don't know the count, if you don't know how many like spaces between, suppose as we know that we need only 5 spaces for every number we need some 5 spaces. But if you don't know what is the space between some 15 to 18, and if you need the length of 25, then you do the function called as np.linspace. Sorry, linspace. And if you know the count and everything, just like for loop, you'll be having a range, not ARRANGE, but a range. Okay, a range, np.a range. So it will define the range and it will answer your queries. So if you want to perform some operations in np.linspace, this is when you know the length of the array. That means when you know how much length you want. That means what is the length you want is 25, but you don't know what are the steps between them. So as in this, we don't know what is the length between 100 to 10 to 100. So if I mention 100 and if I mention 1000 here, if I mention 10, that will be possible, I think. So if you can see, I don't know how many count that is there here. Okay. So as who are present in class, if you're good at mathematics, please tell me the count. So this count, I don't know, but coming to this, I know what is the count. So in this linspace, the last element, what is the 5 are having. So in this array, this 5 will define the gap we need to have between one number to another number. But in this linspace, this 25, this last number is the count that we need to have. So if you remember this, remove these two, you only have 5 elements. If you keep this as 35, we'll have 35 elements. Okay, we'll divide the 15 to 18 into 35 elements. So if you just give it 10, we'll have 15 to 18 with 10 elements. If you have only 9, these are the elements we'll be having 15 to 18. If it is between 15 to 16, and if you want to have 10 elements, I hope what you all know what are the 10 elements we'll be having between 15 to 16. 1, 1, 1, 2, 3, 15.1, 15.2, 15.3, 4, 5, 6, 7, 8, 9, and 10. So just like that, this is the count of the elements we need. This is the last element. This is the first element. Okay. So as it is defined, we need 10 elements that is between 100, 10 and 100. So what are the 10 elements that we can have? 100, 200, 300, 400, 500, blah, so on. So if I want to have a data type of integer, I think I can define that here. So it says that we cannot perform this operation. So let's skip this thing. Sorry guys, I made some mistake. Yeah, it's correct. Oh, we're having some extra brackets. Let me just remove them and we'll just run them again. So these are the things we'll be running. So if you just keep it 1, that means we only need 1 element. So why we're getting 100? Because we will include this element. So whenever you're performing an operation, we will include this 100. Okay, we'll include this 100 and we'll go for the next thing. So if it is 2, we'll go for 100 and some other thing. But if you have 0, we'll get an array is empty and data type is a float. So we need to define the empty arrays. data type, so we are giving it as float. I hope you got my point. So this np.arrange will have start. This np.arrange will have start, stop, and this is a step count. So this step is for the size. Coming to this namespace, this will have start, stop, and what is the number count we need to have. Okay, I hope you understood this point. And protein space will only accept three attributes, that is start, stop, and the count. And this thing will have start, stop, and step. Please remember the differences between both two. So next thing is inspecting the structure and contents of the arrays. What are the arrays we'll be having? We need to inspect the structures and we need to understand this thing. So we are understanding the properties of arrays. That means what are the steps, data types, dimensions, and what we'll be having. So once if you have an array, you'll often want to know what it looks like. So that means if you're having one dimension array, so this is how a one-dimensional array will look like. So what are the things which I've highlighted? This will look like a one-dimensional array. But if you want 2D array, this consists of 2D array. Okay. So you want to know what kind of number it holds and how many dimensions it is. So NumPy will have some attributes which will help you to convert convert a list or tuples into an array of multiple dimensions. So what we'll be doing is, first thing what we are doing is importing NumPy as NP. Second, we are creating a sample array. Okay, we are creating a sample array. That is, we are creating with the help of NumPy. Okay, we are creating a sample array with the help of NumPy, and we are using random. So, and also we're using random for. Okay, if you hover this over this, we can get the what are the info with these attributes we are having. So, random is nothing but it will give you the random integers what you're having. So for 0, 100, and we are having size of 3, 4. That means we'll have 3 rows and 4 columns. So axis 0, axis 1. To keep it 4, and if we keep it 4, we need to get 4 into 4. Okay. Now we got 4 into 4. So we'll analyze this thing. So print. So we have defined an array. We have defined the most random array, that is between 0 to 100. We have an array between 0 to 100. So, and after that, we have defined the data type of np.int of 32. That means we are having 32 int 32. So this int 32 is a data type. So we are having 3 into 4 array of random integers. What are the data type we are having it of integers? So first thing is array.shape. What are the array we are having? This will define the shape. Okay, that means what are the shape you're having? It is of 4 into 4. If it is of some other thing, sorry. If it is of some other thing like 3 into 4, then we'll have that changed in the shape itself. So if you're having it 5 into 4, then you can see the shape is changed. That is of 5 into 4. And as you have mentioned, the D type is of int 32. So as you have mentioned this, it is of same D type. And if you want the dimensions, what is the dimension here? It is of 2D. So as it is of 2D array, we are having the dimensions as 2D. So for this, you need to have this for options called as arr.shape. Whenever you perform this operation, arr.shape, you will get the shape of this array. Okay, whenever you perform this data type operation, that is arr.dtype. Okay, and coming to this arr.endim, that is n dimension. You need to know the n dimensions of this array. And also last thing is you need to know the item size. What are the items you're having into the size of them. So as you have defined them as integers, we'll have them as 4 bytes. So every integer will have 4 bytes, right? So I hope you all know what is the byte size of integers. So the byte size of integers is 4. So as it is having, it tells you that how much memory each individual item will have. Thus, each individual item for int32 is 4 bytes. So now we are reading 3D array. So reading 3D array is not very obvious because we can only print 2D arrays. Okay, 2D is the only thing which we can. 3D is something which we can see in our real life, 3 dimension. Every object will have height, width, and breadth. Okay. Now every object on paper will not have height. It will only have length and breadth. So as we are having a 3D object, it is hard for us to print that on paper. So we'll only have According to specific convention, we'll print the arrays as per the following thing. So if you want to go for np.arrange, so this is something when you have some mathematical function, when you want to perform this, you can perform using np.arrange of 24. This 24 is nothing but of for loop. So it's like for I in range of 24, print I. That means you're printing I from 0 to 24. What are the data objects you'll be having? You can print them. And coming to this, creating a 3D array. So when you want to create a 3D array, you can directly use the reshape option. So this reshape option will have this first thing, will create that. So let me just tell you how we'll do that. So as we have created 2D array, we are creating 3D array. So now we are getting np arrange of 24. That means we are taking 24 elements from random. So not from random, we are taking the for loop and we are taking 24 elements. So how working with 3D elements can be is, so NumPy has specific way. So how we can print them is, we need to reshape the elements. We need to reshape it. So if you want to take that as a 2D, if you want to take that as a 2D, we'll keep the 2 first. If you want to keep that as 3D, we'll keep the 3 first. So what we'll be having is, if you check this, is 3 is the 3 blocks. What are the 3 blocks you're having? 3 represents the blocks. That means what are the sub arrays we're having? This sub concepts, sub blocks are called as sub arrays, are called as this 3. Okay, and the second one is the each block size. So each block is of 2 into 2. So if you are, so 2 into 4. So each block, if you are having 2 into 4, the first 2, if you look at this one, it's of 2. So and the last thing is 4 elements, 4 columns. So let me just convert it to 3, convert it to 4. Now it is saying that cannot reshape the size of array of 24 into 3, 4, 3. That means we're converting into 3 blocks. 3 blocks of 4 rows. So imagine we are having 4 rows. That means 4, 4, 4. Okay. So in this 4, 4, 4, for every 4 rows, you're having 3 columns. That means for first thing, let's imagine this will be in the format of, let's create 4. That means 1, 2, 3, 4. And again, as I discussed, we will have 3, 1, 3, 2. Sorry, 1, 3, 4. 2, 3, 4. 3, 3. Sorry, guys. 3, 3, 3. And 4, 3, 2. Now it is on the format of 4 into 3. That means 4 rows and 3 columns. Now, how many numbers we're having? We are getting 12 elements in the first thing. Okay. Now, as we can see, we have created a structure where we will create 3 structures like this. So, going to create, if I want to create 3 structures like this, removing the extra things. Okay. Now we are having 4 rows, and again 4 rows. Let me just put spaces for our understanding. So as we have discussed, this 3 is nothing but the component which will divide a single array into multiple types. So as this 3 is dividing into 3 types, that's great. Okay. Now 4 is nothing but we are having 4 rows. We're having 4 rows, so we'll have 4 here. This 3 will tell you the columns. So can you tell me how many numbers we are having? So in this we are having 12, 12, 12. 12 is 36. Now we are having only 24 numbers. If we keep this as 36, we can get this. So we need to keep it as comment, guys, because this is of invalid data type. Sorry, let me just put it in comment. Sorry. Now you can see the same thing. So it has printed 4 rows, 3 columns, and 3 things. Why it is printed? Because we are having 36 elements. 36 elements. If you shape it, if you count is 4, 4, 4, 4 rows, 1, 2, 3, 3 columns. 4 into 3, 4 into 3, 4 into 3. If you keep it as 2, it will say that you're getting an error because the size of 36 will not fit into. If you remove this thing, now will the 36 fit in this one? No. What will fit in this one? 4 into 3 is 12. 4 into 3 is 12. Now we can have the 24 count here. Okay. I hope you understood that this 2 is nothing but dividing a single array into multiple sub arrays. Okay. This 2 will get us blocks of arrays. So this 4 is the rows and this 3 is the columns. Now what we're doing, we are printing the 3D array. I hope you understood this one. Give me some response, guys. And also going to the thing which I have discussed, which we have discussed that we'll talk about this in the top session. So these are subsets, slice, index, and effects. So how we'll perform the subset, slice, and everything. So imagine, so as we need to import this numpy, we'll import this for mandatory. Imagine you're having a scoreboard. That means as like for loop, as some persons will be lazy, I'm one of this person. So instead of creating an array of 10 to 90, I have created a array with the help of arrange. So this arrange will give me array with the help of for loop. So instead I can like what I tell you. Instead I can do this thing. So instead of this course, I can create this array directly. That is SCORE. Score is equal to np dot array of. Okay, if I want to print this thing, SCORE. Sorry, we need to have some comma or something. Okay, now if you run this thing, it will tell you this thing. That is what is thing which I have created. So if you are lazy, you can directly use the arrange function. So instead of creating this thing, I'll directly use the arrange function. Okay, this I have used arrange function of 10. That means I can take 10 elements. And also the print score will give you me 10, 20, 30, 40, and some other thing. So what are the array I'll be having? So generally I'll get the array from it in the form of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But what are the arrays I'll be having? I'm calculating with the help of 10 and performing some operations with the help of 10. So if I can bold this thing. So I hope you can understand that 0 to 1 to 10, this is multiplied with 10. So I'm getting this output. Okay, if I print this, I will get this score. Okay, what I'm doing is first score. So this scores of 0. That means this thing. This 0 is assigned to first of scores of last in a list or in a tuple. If you're having indexes from minus, that means we're getting the index from the bottom. That means from the last. If you're having a positive index, that means we're getting from the front. If you're getting a negative index, that means we're getting from the last thing. So in the mid scores, if I want to have the mid score that is from 30 to 60 or some other thing, I'll either get 0, 1, 2, 3, 4, 5, 6. That means I'll get from 3 to 7. So if I get from 3 to 7, it will only consider from 3 to 6. So as you all know in Python, the last variable what you'll be defining will not be considered. We'll only consider before the variable. So as it is given as 1 to 6, we'll consider from this is 0, this is 1, 2, 3, 4, 5. That means we'll only get from 10 to 50. If you check this thing, we'll only get from 10 to 50. Okay. And if you get this alternate scores, that means we are slicing the operation with 2. So after 2, we'll get everything. So after 2, what we're having is 20, 40, 60, 80. So in this slicing sequence, it starts from start, stop, and step. So this start, stop is not defined. Start is inclusive. That means this 0 is inclusive and stop is exclusive. As we have not defined the stop also. So suppose if I'm having a start, I'll keep it as here. Stop is, I'll give it as 9. Now if you run this thing, we'll get it as different output. That means you'll have, let me just keep it a 3. Now you'll have only 0, 30, 60. That means you're having 3 difference. That means you're having 3 steps difference. Okay. What we're having before is we're having only 2 steps difference for 0 inclusive and the last thing exclusive. So we're having only 0 to 80. So if you look at the passing score, this is a mathematical operation. Passing scores, scores greater than or equal to 50. So in the scores, if the scores are greater than 50, we're having this passing scores. So if you look at the print statements, these print statements are nothing but the function which I have discussed above. Import, this is the import we are doing. Scores, let me just so I hope you all understood the difference between first, last, slicing, indexing, and everything. So please give me some responses if you understood this topic. So don't worry, I'll share this notebook with you all, so you can practice with this notebook. And we'll take a short break. We're almost at the end of the session. Okay, we'll take a short break and we'll come back within 5-10 minutes. I hope it's fine for everyone. So in the meanwhile, you can ask me the doubts. So Naresh and Prakash, you have some doubts. So please, can you mention them where you have where you're having the doubts, how to make it init? So I didn't get you where you're mentioning that one. If you are in the class right now, please help me identify at what point of class you are telling to make it as int. And also Prakash, what is the item size that you want me to show you? Okay, I have some item size. Regarding item size. Okay, now if you look at this thing, each axis will start with the index of 0. I hope you all know in the Python also, everything which you're having, it will start with the index 0. So if you want to start something in Python, it starts from 0. In the same way, in the NumPy, it will start from the index 0. So if you figure this one, this, it says that this 2D array, this of one row, this is of one row, and this of another row. So it is a 2D array. It will print this and two dimensional. If you remove this thing, then this thing is of 2 into 2. Okay. So it is nothing but creating a 2D array. So now if you want to convert, like if you want to perform some operations in this thing, so what you'll be doing is perform, let's suppose you're importing the numpy as usual, and after that we are having marks. We are having the marks of students. Suppose it is of subject maths, physics, chemistry, and biology. So these 4 subjects, and these are the 4 students. So for these 4 subjects and 4 students, we're having the marks. The first thing is access third row, second column. That means this is third row, and this is the second column. So for this, if I want to access, what are the indexing that is having? I'll have 0, 1, 2. So it is 2, and it is 0, 1. So it is 2, comma 1. If I want to access thing, I need to print it as marks of 2, comma 1. As you all know, this is the index of 0, index of 1, index of 2, index of 3. So in counting, we'll count it as 1, 2, 3 in a human format. As we all know, the counting starts from 1 to 3. If I ask you how many fingers you're having, if you will count from 1, 2, 3, 4, 5. Okay. But in the machine format, it will count from 0, 1, 2, 3, 4. Okay. If we ask the machine, if you ask the robot, humanoid robot, it will ask the count of fingers it's having is 4. 0, 1, 2, 3, 4. So now if you count this thing, what is the third row, second element? That is third, 1, 2, 3. In machine format, 0, 1, 2. Second element is 1, 2. But in machine format is 0, 1. So 2, comma 1 gives us 89. And if you want to slice the second row, that means it is 0, 1. That means then you will slice the second row. And if you want to want another type of result of second row, then we'll slice the 0, comma 1 again. So from this cell, you'll get the output. So it's the thing you'll be getting. If you slice this thing, that means you will remove this thing. You will get the output for this one, 78, 83, 85, and 80. After that, what you'll be seeing is the type of this thing. Okay, here what you're defining, there is no end element. There is no end element. There is no steps. Now we'll only take one thing. After one, what is the thing we'll having? We'll only take that one. So if you want to know the type of that, we'll after one, what is the array we'll having? What is the type of that thing? So in the last thing, slice all rows, third columns, slice all rows, and third column all students English marks. That means we'll slice all the rows, but you'll only need a third column. That means 0, 1, 2, 3. So this 88, 85, 94, and 68. This third column is of human readable format, 1, 2, 3. But in machine readable format, it's of 0, 1, 2. That means we need the marks of, there is no start. That means we don't need any start. We only need the last thing. We only need the ending thing. That is 2. That means 0, 1, 2. We'll only get the 88, 85, 94, and 68. So 88, 85, 94, and 68. So coming to the slicing all rows, first 3 columns. So we'll slice the all rows and first 3 columns. We'll only get 92, 80, 88, 72. So if you want all students marks in first 3 subjects. So the marks of first 3 subjects is 85, 90, 88. So that means we'll get the details from this 3. We'll get the details from, that means we'll mark where the first column will represent nothing. That means we'll go from first, and the last semicolon will represent the end element. This element represents this thing. End element is 3. That means 0, 1, 2, 3. So whenever you represent 3, it will only take 2. Whenever you represent 2, it will only take 1. Whenever you represent 1, it will only take 0. So whenever you're representing 3, so let me show you. If you represent 2, it will only take this 85, 90, 78, 83, 91, 89, 76, 70, because of 0, 1, 2. So as you all know in Python, the last index, it is not being counted. We only get 85, 90. So if we give the index as 4, we'll get the full matrix. Okay. We need to give the n-1 count. If you want n-1, you need to give the n count so that the machine will understand, and the machine will give us only the n-1. As we need only the until the third row will give us 3. So that machine will give us only 3 rows. comparison the compute time between NumPy and standard Python. So as I have mentioned before, you'll often work with extreme data, so extremely large data sets. So when you're working with extremely large data sets, you'll be having this speed option. So there's a speed advantage is NumPy that is really benefited why we are using this NumPy library. So when you're working with millions and billions of data points, suppose you might think, I won't be working, but whenever some scientist, some data scientist, or some other machine learning engineer in real world companies such as Infosys, Amazon, or someone think, if you're working in Amazon, Amazon is a very large company, you'll be having millions of data points. You'll be having data points of attributes like colors, reviews, the places where they're being sold, every the mostly where they're being sold lessly. So for every data point, you need to perform some operation. So here you'll be having millions and billions of data points. So if you're performing this millions of billions of with, you need to have some speed for performing this operations. So if you're performing it less, you'll be having some time difference. That means you'll be having it will take some minutes for calculation. But if you're performing with NumPy, it will take small speed and will give you it can save you hours. Or if you're having billions of data points, it can save you data days also. So as our laptops and computers, they are not supercomputers. Okay, what are the desktops and laptops you're having? They're not supercomputers. If they're supercomputers, they can perform an operation within seconds. But as they're not supercomputers, they need some computation time. So if you're using this, it will take some computation time. Okay. So why NumPy is faster? Because NumPy will use C language backend. NumPy's core operations are written in C. So as these clear that NumPy is written in C. What are the code we are writing in NumPy? That in the backend it is done with the help of C language. Okay. So NumPy array store more data compactly and efficiently in memory. So with compared with Python list, NumPy will store the data more efficiently and it's helpful for the data storing part also. Okay. So these benefits will help you understand why NumPy is better than lists and tuples. So we can perform some operations. These are the basic mathematical operations. I hope you all know these basic mathematical operations. This is a basic NumPy array. So if you want to perform some NumPy, you will need to import the NumPy. So as we have imported the NumPy earlier, we'll just perform the operation. So this np.mean will represent, we'll have the mean. That means 10 plus 20 plus 30 plus 40 divided by 4. Give me some mathematical calculation, guys. 10, 20, 40, 30. That means we'll be having 70 plus 20, 90, 9 plus 10, 100. 100 divided by 4 is 25. So as it is of 25, so let's type d type is equal to int and check whether it gives us int or not. Sorry, we are in the print statement. We didn't see that one. So I hope you all understood this thing where you're performing operations called mean, median, mode, and everything. So for the median, the middle point will be having input max. What are the array you're having? The maximum element it will return, and also it will return the minimum element in the array. And this STD represents standard deviation. It will perform the standard deviation, and it will represent this thing. So if I want to print, let me just give this condition where I think it will print this in digit format. X is equal to p dot median of ARR. Okay, just take this as int. Let me just print X here. Now we can get this thing. Now instead of like changing in the print statement, as I did a mistake before that we have tried to change the data type in the print statement. But what I've done is instead of changing the data type print statement, I have changed it earlier. So whatever the thing which we're having in mean, it is of float data type. That means 25.0. That I have changed that point 25.0 to 25 with the help of this int conversion. So this data type int conversion I have changed with the help of data conversion Python, and after that I have printed the x. This x is nothing but the mean. So I hope you understood this operations in NumPy where we'll perform mean, median, max, minimum, and something. Now we'll go for the mathematical matrix multiplications. In this matrix multiplications, 1, 2, 3, 4, 5, 6, 7, 8. These are the four matrices we are having. Okay, in these two matrices we are having four arrays. Okay, in these two matrices we are having four arrays. So if you want to multiply, I hope you all know vector multiplication using dot. So we'll be having a function called as np.dot np.dot of a comma b. In this a comma b, it will perform the np.dot. So that means 1, 2, 3, 4 is of single like a 2D array, and 5, 6, 7, 8 is of another 2D array. These 2D arrays will multiply with each other with the help of np.dot. So please refer to the dot products how they'll be calculated. So if you know what is dot product, you will understand this np.dot operation also. So coming to the reshape and transpose. So a is equal to input array 1, 2, 3, 4, 5, 6. This is an array again. So if you want to print a dot t, what are a dot t? 1, comma 2, comma 3 is of perfect, but 4, comma 5, comma 6. If you want to perform the operation of transpose, we convert that 4, comma 5, comma 6 into, as this is of axis 0, comma 3. That means, sorry, we are having of axis 0, like so 1, comma 3. One row, three columns. So if this 4 is of one row, 4, 5, 6 comes under a single row, and we're having three columns here. 4 is one column, 5 is one column, 6 is one column. When we perform the operation of transpose, 1, comma 3 will convert into 3, comma 1. That means 4, 5, 6. We'll have 4, 5, 6, one by one. That means we'll have three rows and one column. That means one column, in this one column, we'll have only 4, 5, 6. I hope you have understood my point. 1, 2, 3 will be having the same thing, but coming to this T, we'll have this transpose and we'll perform a dot product. So in this reshape, I'll perform this a dot reshape where we're converting into three rows and two columns. So 1, 4, 2, 5, 3, 6. 1, 2, 3, 4, 5, 6. So now we're performing the concatenation and stacking. So we have performed, like we have came into the last topics that we'll be discussing in today's class. So this concatenation means joining arrays together. So what are the arrays we'll be having? We'll join them together. The arrays which we're having is 1, 2, 3, 4. So concatenate x comma y represents, we'll join the ends arrays from 1, 2, 3, 4. I hope you understood this point. If we're having 1, comma 2, comma 3, and again, that means you'll have 1, 2, 3, 3, 4. So this is the end of today's class. NumPy is more than just a Python library. It's a backbone of numerical computing in Python and a core building block for data science and machine learning. So that's it for today's, guys. I hope you have understood the session and enjoyed this session. If you're facing any issues or if you're having any doubts, please contact us in Q&A. Thank you for suggesting some answers, guys. I can see that if you of you are enthusiastic regarding the session. My screen is visible to everyone right now. So one of the students suggested that what happens if we perform the dot as type. So let's check. So this works well, guys. So if you perform dot as type in the print statement, it will convert this entire thing into a single. So it will convert this into a single function and it is performing. But whenever you keep using comma, sorry, but whenever you're giving comma, this will be considered into two statements. So when you're having two statements in print, you need to define one statement in columns. So when you define one statement in like columns or some other thing, not the columns. So this thing, I don't know what we'll call this thing. So then it will be useful to identify for the machine. So if you give it as comma, it is taking it as another statement. So as long as you're typing the as type of int, it will take a single thing with a single function. That's it for today, guys. If you're having any doubts, you can ask us. So in the upcoming self-learning session, that means you'll be having a self-learning tomorrow. In tomorrow's session, I want you to explore explore the NumPy more further. Okay, explore NumPy more further, and I want you to take a basic look into the other libraries, that is Pandas, Matplotlib, Scikit-learn. So if you're having enough time, we'll discuss every library. But as of today, I've understood that we discuss every topic in detail. That means we won't be having the enough time for discussing. So I want you all to look some basic introduction to the libraries. So even if you don't discuss that, you need to have some basic introduction. If you're not having time to discuss them, I'll give you some notebooks, just like the notebook which we're having right now. I'll give you some notebooks. So I want you all to perform operations. After performing operations, you'll get to understand how these libraries work and why we need these libraries. I hope you understood the session. Thank you for joining the session today, guys. If you're having any issues, you can ask us right now. If there is no issues that were mentioned, then we can end the session.